Before we get started, we need two installations. The first is Node.js, which is a platform built on Chrome's JavaScript runtime for easily building fast and scalable network applications. We can find download versions and instructions at nodejs.org. If we click the navbar download section, we can see 32 and 64-bit versions for Windows, Mac, or Linux users. When we install Node.js, we are also automatically installing npm, which is a package manager for Node.js that allows us to download packages, or modules if you will. A module or package is any file or directory that can be loaded by the Node.js require function. The next installation that we need is Express. Express is a fast, unopinionated, minimalist web framework for Node that provides a robust set of features for web and mobile applications. To use Express, we grab the install command to run in our terminal. Once we run this, it's going to be saved in our dependencies in our package JSON. You'll see that I'm running the command npm install express with this additional -- save flag. What that flag does is it saves Express into our dependencies. Once it's installed in our dependencies, we have Express and it's ready to use. But just to be sure, we're going to want to run a check of versions for npm -- version, which we do have the most current version at the time of this recording, node -- version, and express -- version, just to be sure. We have all three, and now we're ready to begin. Before we build our app, I'd like to demonstrate Node's REPL environment. REPL stands for Read, Evaluate, Print Loop. And in this environment, we're able to write JavaScript in the command line. We're able to write simple arithmetic, or we're actually able to write functions. Here I'm going to write a function that returns a console log message. That message is simply going to say, hello from Node.js. When we call hi in the terminal, as we are right here, all that's going to return is confirmation that in the memory we have a function and its name is in fact hi. But if we want to invoke this functionality of the console log and the hello, we need to add the opening and closing parentheses. Once we do, we activate the function and we get our message. Once finished, we can escape the Node shell by pressing Ctrl and C at the same time twice. Node is also able to serve files. Here in hello.js, we have a console log that returns the string greetings from hello.js. If we run node followed by the file, you'll see right here in the terminal window we get greetings from hello.js. Now let's go ahead and build an app. The next thing we're going to do is create a very simple application. This application is going to be a Hello World example that stands as proof of concept. This example will use the least amount of code to produce a single end route that will populate the DOM with the string that we choose. The first thing that we need to do is to use the require function so that we can access the Express module and we can use its many methods. To do this, we simply assign this variable Express the entirety of the Express module. Below, we're assigning app, the variable, to an instantiation of Express. So every time we use app, as we're about to right below, anything that we chain that is dot and then the method from app is going to be a method on the Express library. So right here we're using the .get method. The .get method takes two parameters. The first one is the end route and the second is a callback function. That callback function takes two parameters, one being request and the other response. When we hit the /hello endpoint, it's going to fire off this function. Then what the function will do is attach to the res object the .send method. That method is just going to send a string that says hello from index.js. The next thing we need to do is type out app and then .listen, which is a method that we're going to pass in the port number to. Once we save this, we can go back over to our terminal, and if we run node index.js, it's going to run the code that's inside of this file. When it does, you'll see that we have this blinking cursor down below. That means that the server is running. So if we go to our browser and we look at localhost 3000/hello, we get our message, hello from index.js. Our route was a success. Your code will be much easier to manage if you are able to separate your code into different files. Ideally, you would separate your program into files that contained no more than one function or component. If you have a complex app, you'd have to scroll through hundreds of thousands of lines of code to resolve any issue occurring in your program, which can make debugging very difficult. To handle this modularity, JavaScript comes equipped with imports and exports. In order to use a function from file B in file A, we have to export the function from file B and import the function into file A. For example, here we have a hello.js file, and all that we have in this file is a string that says greetings from hello.js. Now, in order to use that in this index.js file, what we need to do is set its value equal to module.exports. What this does is it puts a wrapper around that string in a nice little package and makes it so that you can transfer it from one file to another. In this case, we're using module.exports to export into the index.js file. And here you can see on line 3, we are declaring a variable in hello, and then we are assigning to that variable the value of everything that is inside of the hello.js file. And the way we're doing that is with the function require. Now, you see down below on line 9, we have a console log, and all we're doing is returning the value of the variable hello that we declared on line 3. So if this works, what should be happening is hello.js, the file, should be sending over the string greetings from hello.js, assigning it into the variable hello, and then we're simply going to console log hello to our terminal window. Before we do that, let me comment out our server just so that we can streamline this lesson. Now, if we go to our terminal and we run node space index.js, the only console log we have in there is the one that is reading greetings from hello.js. So we successfully exported from hello.js and successfully imported into index.js. Now, in addition to this, we're going to want to download something called Nodemon. And Nodemon is a package that updates the browser without restarting the server. So as we work and we build our files, instead of having to start over our server, start it back up and check to see if our changes were the desired effect, we can just keep on coding and jump from our editor back into our browser, back and forth, and we won't have to do any extra work. So to install Nodemon, we want to go to our terminal window and we want to type npm install -- save -dev followed by the package, which is Nodemon. What this is going to do is it's going to save Nodemon as a package into our dependencies into our package.json file. So we go ahead and load it, and we can see down here in our dependencies we have express, and as Nodemon is loading, eventually we will have Nodemon pop up in our dependencies right down here. Now it's useful for require.js to be used because let's go ahead and take a look and see what sort of warnings we have. Now don't worry if you download a package or install a package. Sometimes you're going to see that there's a warning, like these yellow warnings right here. Sometimes software is updated and you need to have a more current version. That's okay. It happens all the time. If we scroll down to the bottom and we look, we actually see that we were able to download it. And if we go into our dev dependencies, here we have Nodemon. So what that means is if anyone else is going to download our software, all they would have to do is run npm install, and Node would go and grab the dependencies and the dev dependencies, and it would load them so that they could be accessed by the program itself. So that is how we use require.js. Now we're going to take a look at creating multiple routes, including subroutes and routes that use middleware. We can create a route, let's call it /example, and we can use res.send to send a message to the browser when that endpoint is hit. Looking at the method on line 5, we can see that the first parameter passed is the endpoint, and that endpoint, when hit, will trigger the callback function. That function will use the .send method to attach a message to the response object. So when we look in the browser, we should see the message, hello from example route. Let's jump over to our browser and type in localhost :3000 /example. Here we have hello from the example route written onto the web page. That's exactly the behavior that we expected. Now, if we had example / another route, then we would have a subroute. We have on lines 9 through 12 and on lines 13 through 15 two such subroutes. When we hit the endpoint example /C, we would expect to see the message hello from subroute C. When we hit example /B, we would expect to see the message hello from subroute B. Let's jump back to our browser and test this out. So we have localhost 3000 /example /C. And in fact, we do see hello from subroute C. That's courtesy of the .send method, which again is working on the response object. If we come back over to the browser and just to confirm this further, we use localhost 3000 example B, we'll see that we get the message hello from subroute B. And again, that is triggered by the callback function. When the endpoint is hit, it activates this line of code, and the .send method sends this string attached to the response object. Now, I'm going to talk a little bit more about middleware. On line 17, we have a callback function named callback1. If you look at the parameters, you'll see that we actually have 3 parameters. You'll notice the 2 that you've seen before, the rec and res, as per usual, but in addition, we have next as a 3rd parameter. The next function tells your code to move on to the next middleware function, if there is any at all. Now, if we do not add the next function, the code will get stuck on the first callback. It is imperative that we add this. You'll see that on line 19 right here that the function is called and actually invoked, and that is what allows us to move on to callback 2. So if we jump down and look at example route D in this .get method, you'll notice that we have 2 callback functions, one right after the other. The reason that we are able to structure our code like this is due to the next function, which again will tell our code to move on to the next function in sequence. So when we hit the endpoint, example D, the code will fire off a console log that will be printed to the terminal window. And the second function will use the .send method to write a message to the browser. Hello from D. Let's go ahead and jump back into our browser and check out this functionality by hitting localhost 3000 example/D. Now, not only do we have our message that was sent from .send, we also can jump over into our terminal and we should have this log printed. The response will be sent by the next function. Over here in our terminal window, we see that we do in fact have the response will be sent by the next function. That is perfect. Next, we're going to look at passing middleware functions in an array. So here on line 42, we can see an array of 3 callback functions. These are the functions that are declared above, and they're being passed as a single parameter all at once. Now, when we hit the endpoint, example C/middleware, in the browser, we will see the message from callback 3 on the page. See, if you look up here, callback 1 has a log, callback 2 has a log, callback 3 also has a log, but I added in a .send method with a string to be printed to the web page just to show us and let us know that those callbacks were not only all fired off, but the next function worked in 1 to call 2, and it worked in 2 to call 3. So let's go into the browser and see what we get when we hit example/C/with middleware. C with middleware. Excellent. So res.send printed the string callbacks triggered onto our web page, but more importantly, let's go into our terminal window and take a look and see that callback 1, that's its log, callback 2, that's its log, and callback 3, it sends a message that says hello from route C, which in our code we can see right here. So, in conclusion, there are many types of middleware. Some of it is simple and can just tell date times. Some of it will print to the console. Some of it will print to the screen. And some of it has far more important functionality like parsing data as it comes in. And that is middleware. Middleware functions are functions that have access to the request object, response object, and next middleware function in the app request response cycle. These middleware functions are used to modify the request and response objects for actions such as parsing request bodies or adding headers, just to name a few. Our middleware is going to use the inbuilt JavaScript function Date.now, which will return the number of milliseconds elapsed since January 1st, 1970. This is a simple example to demonstrate how middleware can be used to append data to an existing request object. Our middleware will be called for every request to our server. So after each request, we will get a message in the terminal that shows exactly when the request was made. Let's jump over to our terminal window. We're going to run Nodemon to start our server. And again, it's going to watch so that if there is any change made, it'll automatically restart our server with the changes made, so we don't have to use our time stopping and starting the server. Now that it's running, let's go into our browser and we're going to go to localhost 3000/hello, just as we've specified here in the route. Once we hit enter in the browser, we get route on hello. This is the message that we specified down here in our app.get method. If we go over to our terminal window, you'll notice that we have a very long number here, and that's the number of milliseconds that have elapsed since January 1st, 1970. And you'll see preceding that number we have a message. A new request was received at, and that is exactly the string that we added in to our middleware. This is just one example of how middleware works. There are many different use cases, but this is just to demonstrate in a simple way how we can use middleware to modify our request and response objects. Now that we've seen how to create a route with an endpoint and callback function, now we're going to use the router methods provided by the Express package. First off, let's start our server with Nodemon and run the existing route we have coded in our index.js to prove that it is still working. So right now we have app.get with the endpoint hello. So let's go over here and hit the route localhost 3000/hello, and you'll see that we actually get our get route on hello from index.js. Let's make a small change again just to prove to ourselves that it is in fact the same route and the same message. And if we come over here really quickly to our terminal, we notice that Nodemon was indeed watching, and when it saw a change, it restarted due to that change. Okay, let's jump back over to our browser. Let's refresh this same route, and you'll see that the added from index.js does in fact populate the DOM, and we now have confirmation that we're working with the same route. Okay, next thing we want to do is to create the same route using this time the Express router. To do this, we use a separate routes.js file here that will contain our GET request to the hello route. This routes.js file will use the require function to import the Express package, and then we'll declare a new variable router that will be using the Express router. So we want to set the router equal to the entire Express framework upon which the router method will be operating. Now at the bottom of the routes.js file, we need to export our router. This is the same thing that we did in the hello.js function from the last video, except in that example, we only passed a string, greetings from hello.js. And in this routes example, we're going to be actually exporting some functionality that will be used in our index.js file. So what we want to do is come over here to our index.js file. We're going to reuse the require function to take in our hello route that is now over here in our routes.js file. Okay. Line 3, this declaration of hello is going to require in the entirety of that file's functionality. The next thing that we're going to need is to use the .use method upon which it will be operating on this express instantiation. .use is going to listen for the endpoint /hello, and when it hears that endpoint, it's going to activate hello, the variable. And again, that is declared up here on line 3, which is in reference to the entire routes.js file. So let's go ahead and run this. Before we do, let's go ahead and comment out our previous route. Okay, now all that this app is depending on is the hello that is requiring in this entire function. Okay, so we do have Nodemon picking up on these changes, and it restarted. So now when we go back to the browser and we hit refresh, we're going to get a route that was hit on index.js, and we do get our string returned get route on hello. That's coming from our routes.js file now. Let's go ahead and add to this message and just say get route on hello from routes.js, just to prove to ourselves that it is coming from the right source. And again, if you see over here, Nodemon picked up on the change and restarted again. This is why Nodemon is so useful. We jump back over to our browser, and if we hit refresh, now we see the message that we wrote in our routes.js file, get route on hello from routes.js. The reason why we want to use this structure is because you will be defining multiple routes on an app, and sometimes it can be very tedious to maintain. So we want to separate the routes file from our main index.js file to keep our code readable and keep it so that it's more maintainable, meaning if we have any bugs in our program, it'll be easier to find.